Hello everyone, so this is Ambrish Singh, and in today's video I would like to show you how to use AutoCAD to generate a sequence of points and extract the XY coordinates of these points. You can use this technique to create a toolpath that you can give to a 3-axis CNC machine, or you can use it for some other purpose, whatever purpose you have. So what I'm trying to do here is I have a curve in SolidWorks, and I will generate a sequence of points, equidistant point on this curve, and later on we will process this in Excel, and we will have the XY coordinates of these points. So let's see how we can do that. So remember, you can use these XY points to, as I mentioned, you can use these XY points to feed it into a CNC machine, or you can use these sequence of XY points to for any other purpose that you want. So if you have let's say for example you want to design a custom toolpath, so you can design a custom toolpath, test out the toolpath whether it works or not, and if it works you can then create a generic algorithm to generate the toolpath, but for initial testing you can use this technique. Okay, so now we are in the AutoCAD environment. So let's first click on Start Drawing. And the three things that we need to do is we need to set the limits, we need to set the units, and then we need to set the grid display. So first I will give units command. I want to work in millimeters, so it's set in millimeters, that's perfectly fine. Then I'll set the limits command. This sets the workspace. So the lowermost coordinate of my workspace is defined by 0, 0, and the uppermost corner is defined by 210, 297. Now this 202 at 210 and 297 corresponds to an A4 size sheet of paper. You can select any other dimensions that you want. Now we will get the grid display. Grid display. So currently the value of grid display is set to 3. You simply press in 2 and then you press in enter. So now the grid display is set to 2. So what this means is that the grid display, when it is set to 3, it plots the grid lines in the infinite 2D space that we have here. But when you set it to 2, what happens is the grid lines are within the bounds or within the limits that you have set earlier. So currently the grid display command has erased those grid lines, but actually we have zoomed out. So what we can do is we can give zoom all command. So just simply press Z enter and A enter. So now you can see that you have the grid lines which is within the bounds of our limits. So this corner is 0, 0, and then this is 210 and 297. Okay, so let's say we have a shape, a freeform shape. So let's use a spline tool to create a freeform shape like so. And let's see whether these two are closed. It's not, so I'm going to just move it in. Okay, let me make it so that it looks a bit continuous. Okay, so now this is the shape. Now you want to generate a sequence of points on this shape. This sequence of points will then be fed to a CNC controller, and you will have an end mill cutter trace out this curve. So how to do that? So you need to extract a sequence of XY points on this curve. So the first thing that you need to do is you need to set a directory. So the first thing that we need to do is we need to set a directory, a working directory. So what I will do is I'll navigate to this directory, pictures directory, and I'll create a new folder, and I'll call it as XY coordinate, XY coord extraction. Okay. So this is my directory that I want to work in. Next, what I will do is I'll just simply copy this directory, and then I'll come over here and I will write log file, log file, and then path. You see this log file path. I'll press enter and I'll paste the directory here. Paste the directory here. Wait a minute, I will give again log file path, right? And then I will paste the directory here. You will see that this I have pasted this here, and I'll press enter. That's the new value of the log file path. Then we need to turn the log file path on. We need to turn the log file path on, that log file on. So to do that, we'll give log file, yeah, log file, and then on. So now we have given the log file on. Next, what I will do is I need to create a sequence of points. To create the sequence of points, I will give the measure command, or I will give the me command. The shortcut is me. So I'll give me, then press enter. Now it says select the object to measure. I'll select this. Then it's asking me to specify the length of the segment. So between two successive points, what should be the length? Between two successive points, what should be length? Should be the length. So let's say I want 0.5 millimeters between two successive points. So I'll give 0.5. Now, believe it or not, this curve is now used to generate points. There are points at every 0.5 mm on this curve. It's not visible because of my point type setting. To change the point type setting, I will give p type command. P type. I'll select, let's say, this is the way we are representing the point. Let's say I'll select this one and let me reduce this point size to 1 and click OK. And now you can see that actually these are my points. You see, these are my points. These are my points. And then this was my curve. And you can see on this curve, a sequence of points. And between 2 points, we have 0.5 mm as the distance. So these are all equidistant points. They have been generated. So far, so good. Now we need to extract the coordinate of these points. What is the extract xy coordinate of these points? So to do that, what I will do is I will just right click. Wait a minute. I'll right click. I will click on this quick select. From this object type, I will select only points. And then I will select, okay, only points. Yeah. So only points I will select and then click OK. So what this has done is that it has only selected these xy points, these points which have been generated. This curve has been left out. So having selected the points only, what I can do is I can give a command called list, L-I-S-T, list, and press enter. Now what you have to do is you have to keep pressing the enter. So it's a long press. So it will keep on selecting these points and it will export those points to the directory. So you are just simply holding the enter key. So I'm simply holding the enter key. And when it has selected all the points, you will see that this is now running clear. So no more points are being selected now. Okay. So all these points, the coordinates of all these points have now been exported. Now what I can do is I can give log file off. Log file off. So now if I go to this directory, you can see I have this list of points. So let me open the Excel file. File, save as, I'll go to browse and then I'll save this here in this directory. XY chord extraction. Right. Next, what I'm going to do is I'm going to simply open this. This was generated with the AutoCAD. Control A and then Control C. Will come back to my Excel file and I'll paste it here. You have see I have pasted it here. Now I'm going to slightly manipulate this so that it becomes much more easier to work with. So we can extract the data which is required. So what I will do is I'll go to data, then click on text to columns, click on delimited, click on next, select all this, and in others you just simply press equal to and then click on finish. Now you see we have split the data into separate columns. Now you will come to this column where it says AutoCAD, select this and then apply a filter. So once you have applied a filter, you will see that this drop down symbol will come in. You click on this drop down symbol, click on select all, and then click only this select at, then click OK. So once you have done that, you can see this is my X value and then this is my Y value. So this is X and then this is Y. So what I can do is I can simply click on this and I can delete this. So I'll delete this, right? So this is the coordinate location. So I'll control C, open a new sheet, and then control V. So this is the X and then this is the Y. These are the XY coordinates of the points which are on this curve. Okay. So now a little bit more manipulation we can do so that it becomes more conducive for CNC machines. So for that, what you can do is you can let's see how you can do it. You can just write X here and you can write Y here. And what you can do is you can concatenate these two columns. So what I will do is click equal to, give concatenate command. So what you need to concatenate X, comma, this, but this is going to remain fixed. So I'll place a $sign here, $sign here. So it has now concatenated, and similarly you will do concatenate, click on Y, comma, this, and then this has to be fixed. So this is there, this is fixed, click enter, and then you simply double click. Okay. So now what I can do is I can again select these two, control C, just a second, control C, and I can place it as plain text, and then I will write here G01, G01, and we will expand it to all the columns, and now you can see these are the coordinates, and you can specify a feed rate. So in fact, I can show you that these coordinates are indeed the coordinates of the points which were generated on the curve in the AutoCAD. So what I will do is I'll just select all of this, control C, copy it, and paste it in my NC viewer. So this is a site, ncviewer.com. You can simply open this site and you can paste your Gcode and you can create plot. We'll zoom out. We don't know where that plot is. Yeah, here it is. So you can see it has now generated that plot. So if I were to go here, you can see this point is, if you just simply click on this, then plot, okay. So you see this is my cutting tool here, or your laser beam, or whatever it is. And now if you scroll down, you can see that this point, this marker is actually moving from point to point, and it's going to trace the contour. You can see here that this is moving, and these are equidistant points, right? So it's moving. And it's still moving, moving, and then that's it. So that's how you generate a sequence of points on a curve in AutoCAD and then extract its XY coordinates. What could be the possible applications of this small little trick? Well, I find that sometimes when you're working on a toolpath, you're trying out a new toolpath, but you're not sure whether the toolpath is going to work or not. You don't want to invest too much time into it. So you need to prototype it. So what you can do is you can use this AutoCAD environment. You can create a toolpath using the tools of the AutoCAD. So so let's say this is the type of toolpath that you want to design. So using the tools of the AutoCAD, you have generated this toolpath. You want to create a sequence of XY points, feed it to the CNC machine to test it out before you can write any generic algorithm for it. So you can do that. You can just simply give the ME command, select this continuous curve. Let's say I want my sequence of points to be spaced at 1 millimeters. So I'll set 1 millimeters, and you can see again, I have generated these sequence of points. And using the quick select command, you can again extract out its XY coordinates. So this is possibility. So this is one application. Another application that I have used is testing out the during laser cutting, testing out the cut sequence. So for example, I want to I have this kind of a contour like this. So what I will do is, when I used a commercial software package and it gave me the toolpath, so what happened is it gave the toolpath, the cutting toolpath of this contour first, followed by this contour. But what I wanted was reverse, opposite of it. I want to cut this contour first, then this contour, then this contour. So that's how I can stage, or I can create a sequence in which contour I can decide which contour will be processed first, followed by which contour, and then followed by which contour. So these are some of the possible applications. I'm sure you will come up with your own applications. So it's just a simple trick. It's nice to have in your back pocket. Whenever you want, you can use it. So this is currently limited to, I guess it's to 3-axis CNC machining. I'm not sure how you can use it for 5-axis CNC machining, although you can create curves in 3 dimensions, and then you can write an algorithm or some sort of a post processor to convert it to the type of CNC machine that you have. All right, so that's it for today. That's it for this tutorial. I hope this would be useful. Thank you.